We're here at OFC in San Diego, California, and I'm with Rob Shore from Infinera. Hello, Rob.
Hi, thanks for having me.
And for those of us, for those watching this on video, we are at the Infinera stand, or we're at the Home and Garden Department in Lowe's.
Yeah,
because we have greenery behind us, we have some 2x4s or something like that. Anyway, as soon as I get done making fun of your booth, we actually have some business to talk about what Infinera is doing at this show and in the market generally. There's three things I want to hit on because there were announcements of happening recently. The first is by far the coolest sounding, ICE 6 Turbo,
Yeah.
which I assume is a new kind of sports car that you guys are building.
That's exactly right. An electric vehicle, of course.
Oh, great!
Yeah.
No, so this is an update to the ICE 6 platform. I assume this means a faster transmission, more bandwidth. What are the perks of i6 Turbo?
No, it's a great question. I mean, when we launched i6 about a year ago, we knew, I mean, it was already based on feedback from customers, the best performing optical engine at the time.
Okay.
But we knew there was more kind of gas in the tank, so to speak, that we could further tune the engine to get even greater performance out of it.
Keep up with the auto references.
Yes, exactly. And that's exactly what we did. Essentially, we refined the algorithms on the engines. We further improved the assembly process of connecting the optical front end with the DSP and the manufacturing process. And we've been able to squeeze about a 30% improvement in performance out of it.
Okay.
What does that mean? It means if you buy a single optical engine that's capable of 1.6 terabits, so two 800 gig wavelengths, it just enables me to take those 800 gig wavelengths even further, about 30% further than the original i6, which was itself about 15 to 30% further than anybody else could do in the industry.
Okay.
So again, the meaning for end users, right, that for our customers are, they have capacity, bandwidth, services they need to transport. Let's say they've got four 400 gigabit Ethernets they need to transport. The question is, how many optical engines do you need to buy to be able to transport those services over a given distance? And i6 enables you to transport those services with fewer optical engines, less equipment, less power, less money.
Right, because every single time, when you reach the end of that theoretical distance, more equipment goes in, more stops, like you said, more electricity, power cooling, all
Exactly
that stuff.
right. Yep.
Okay, so that clears it up. So it's an incremental kind of improvement in the optical engine that was already, doing well. And what is the next thing I wanted to talk about was let's see, we want to get to the thing with Windstream. That
probably makes the most sense last.
Yeah, let's do that last. What was in between?
So the
optics.
i6R, yeah. It was really two key things. i6R is our pluggable optics, so it's these coherent optical engines in these pluggable form factors. One of the things we're recognizing, right, coherent began its life in the core of the network because it's an ultra-scalable optical transmission solution. But one thing we know about bandwidth is it grows.
Sure.
Wherever it is, it grows.
Yep.
And eventually, virtually every connectivity application will eventually need a coherent engine to support the capacity requirements. So we're seeing those needs today move not only into the metro, but in the metro edge.
Okay.
So there's new classes of coherent engines that need to be developed, optimized for not only those parts of the network, the edge of the network, but also the types of traffic patterns you have. So in the core of a network, it's really all point-to-point, big giant locations with lots of information between them. When you get closer to the edge of the network, the traffic pattern becomes definitively hub and spoke. Think of a mobile network. Big giant radio, 2,000 subscribers.
Right.
Optical engines to this point today haven't been built. They're all built point-to-point. So the first thing about i6R and XR optics in general is it's really the industry's first optical engine capable of supporting multi-point traffic.
Okay.
So one end, big engine at one end, lots of smaller engines at the other end. We also never do enough justice in talking about the fact it can also be used for point-to-point, right? So it does point-to-point ZR plus applications as well. Those will probably be the initial deployments.
Right.
But it's that same engine can just be software configured to now support multi-point as well as point-to-point.
So it's not a dead-end investment when you're, it might be a bit, it might be a bit rich to use this, for point-to-point. Right out of the box, but maybe the idea that you can upgrade it and evolve your network softens that.
Well, no, it'll be the same as any other point-to-point pluggable solution out there. It's exactly the same, all the same profile characteristics and all that kind of stuff, with just the added benefit of if you want to use it for multi-point applications, it'd be the same engine. One of the interesting things that really we were a little bit surprised to hear this from customers, but the number one reason that they're excited about this technology is what they call generational upgrades. So let's say they have a point-to-point application today, 2 routers, 400 gig, right between those routers. Well, inevitably, you're going to want to upgrade one of those routers.
Right.
The next generation router, which might have 800 gig ports on it. Well, there's no way to connect the 400 gig port to the 800 gig port directly.
Right.
There's only 2 options. Either I have to put a 400 gig laser in my 800 gig port, throwing away half the capacity of the port. Nobody wants to do that.
Right.
Or I have to put another aggregation device in front of it to aggregate 400 gig and 800 gig. That's another device. Nobody wants to do that.
Right.
Well, with XR optics, I can start with point-to-point. I upgrade one side to 800 gig. I can put an 800 gig laser in here, fully utilizing the port, connect this 400 gig to it, so having to do nothing on the other end of it, and then I can use the other half of the port to connect to another 400 gig.
Okay.
So seamless upgrades, still enabling you to use the full capacity of the ports of this new router and having to do nothing on the other end of it.
Yeah,
so that's one of the really key things that people like about it, even besides hub and spoke traffic, is these generational upgrades.
Oh, that's interesting. And the thing for service providers too is just the whole, the fewer times they can, either add equipment or add ports in any in any network configuration, whatever it is. That's why I think that the hub and spoke thing sounded so interesting. That's just straight up reduction of ports used, reduction of dollars spent. The whole thing.
Well, and the nefarious, and the biggest enemy of network operators is the dreaded truck roll.
Yeah,
right?
Sure.
So just reducing the number of truck rolls, that by itself is a huge economic benefit for customers.
Okay, last thing for this particular update, you're doing something with Windstream. What's happening there?
Yeah, it's a really interesting innovation, and again, all kudos to Windstream on really kind of pioneering this, and I'll give credit to Kim Papakos at Windstream, a really visionary approach to the way you build optical networks. We've been using ROADM technology for a long time. Okay? Super powerful, optical express signals in between, super cost effective. There hasn't been a tremendous amount of evolution in that technology for quite some time. This kind of node on a blade is really the first substantial evolution of that technology, and one of the things that it really focuses on, besides the fact it reduces cost and shrinks to make these things more cost effective, that's obviously a significant portion of it as well.
Sure.
But it's really the first the first ROADM-based solution optimized for coherent-based transmissions.
Okay.
So right now, optical infrastructures treat all optics the same. It's just light.
Yeah, right.
They don't really give you particularly good visibility into the actual spectrum that is traversing that fiber. This is really the first ROADM-based solution that can really give you an extra layer of control and visibility over coherent signals as they go through the fiber. Coherent signals are vastly more complex than a direct detect. So there's a lot more information you can glean from those signals if you have the right tools. Why they want to do this is, okay, great, more visibility, you get better reliability, all that kind of stuff. But the key thing is it's going to enable new types of services. So one of the things that they're talking about is this idea of enabling this kind of virtualized optical infrastructure. As they deal with these cloud-based service providers, right? And these guys, they build big giant data centers and fibers between them, but as they push things like edge compute, and they have these metro infrastructure of 20, 30 edge compute locations that they want to interconnect, trying to build a fiber infrastructure between those is really, really hard. And what Windstream wants to do is give them a better option, right? They don't have to buy bit-by-bit services. They can sell them essentially like a slice of the spectrum. Hey, you get this terahertz of spectrum between these 20 locations, and you essentially have your own private network feel without having to do any of the fiber work.
Okay.
And you're paying a flat fee for the spectrum, and then you grow the network as you want. You don't pay anything extra as you put higher speed transponders on the endpoints. So it's all the benefits of a private network without having the hassle of laying all your own fiber. then it really leverages, in this case, Windstream's one of the most valuable assets they have, which is this extremely diverse and extensive fiber infrastructure, and they can now sell portions of that to some of their customers. But you need this enhanced functionality in your optical network if you want to manage spectrum to that degree.
So this is the wired version of network slicing as we know it on the mobile side or on the 5G
I mean,
side.
two good comparisons. Network slicing is a great comparison. Same thing with IP-based virtual private networks, VPNs.
Right.
It's the optical equivalent of that.
Yeah, because that makes more sense for the service provider too, because not every private network customer that they have is going to utilize the full capacity of the equipment investment.
Yep.
Or maybe they need room to grow and they can't tell. But either way, they can kind of buy with that in mind and not do themselves a disservice, having to turn down business or whatever.
Well, that too, yeah. And now they can have a single infrastructure to support kind of the legacy, I'll call it legacy, but the residential, small, medium business. And that same infrastructure can now support these hyperscale customers that need terabits worth of capacity between locations.
Okay.
And even those data center operators love this concept because the last thing they want to do, two things they don't want to do, buy bit-by-bit services. In other words, I got a terabit worth of capacity through 30 locations. That becomes really cost prohibitive.
Sure.
They also don't want to have to build their own network because you'd think it's counterintuitive, but it's actually easier to build a long-haul network than it is to build a metro network. You think long-distance fibers, but you've got lots of options for fiber paths. You can take the easiest path. When you do it a metro, you don't have that many options, and you've got government, private land ownership, regulations, constructions. It's really, really challenging. So if they can get the benefits of a private network without the hassles of having to build it, that's really powerful for them.
Great.
So it gives Windstream an opportunity to really provide a differentiated service.
That's good. Well, I think we should leave it there, and I should let you get on to your other appointments. Thanks very much for watching and listening. Rob Short, thanks for your time today. I appreciate it.
Yeah, my pleasure. Thanks for having me.